My name's Nick Dewhurst. I'm the president of Boothroyd Dewhurst, and I'd like to take a few minutes to show you how you can use our DFMA software tools to explore the cost of manufacture of things around the world, but also to understand what the impact of design decisions that you're making could be on what regions of manufacture might actually make most sense from a cost perspective. So if I start out looking at a simple part, I'm going to open up this end plate analysis that I've worked on. And you can see here that we've brought in a CAD model of the part, and we have gone through and done an analysis, making decisions about part geometries and material types. And you can see it's a laser cut part with a press brake used to do the bending. And then once that sort of baseline part analysis has been established, you can see here a cost of $2.16 for that part. Then I can copy and paste these analysis tabs, and using our material and profile selection dialog box, I can choose different regions of manufacture and different materials and even different processes if I wanted to for the production of that part. So what I've done in each of these examples is I've kept the materials and the processes the same, but I've changed the region of manufacture. So you can see here I've taken this US analysis, I've changed it to China, and I've recalculated the cost. Now in each of these cases, I've assumed a 10% profit margin for the supplier. It very well could be that those are different in different regions of the world for different suppliers that you have. And you could obviously edit that to be reflective of your own reality. I've made that across the board assumption about what the profit margins are in each of these. And so if I wanted, I can use the reporting tools in here to look at, let's say, this cost totals graph. I can stack the bars here, and I can look at the cost in the U.S., China, Mexico, and let's say India. And there's my cost of manufacture in each of those different regions, and we could choose which one would be the low cost and maybe move forward with that. And so that's how you can use our new global costing data to uncover the cost of manufacture of parts at the piece part level and help you with supplier negotiations and sort of strategic sourcing decisions. However, you can also apply these things at the product level. And so here what I've done is an analysis of this motor assembly. And if you have worked with us in the past or looked at any of our information in the past, you're undoubtedly familiar with this small little product. It's a little motor device that's used to control the gap between two rollers on a printing press. And so what I've done here is I've taken the default design for assembly analysis for this, and I've included the cost of manufacture of the parts that would be manufactured. They're not off-the-shelf parts like this sensor and the set screws and fasteners and things. And I've done cost analyses of them using our DFM tools in different regions of the world. So if I want to see the cost analysis that I've done for this standoff, I can just right-click on it. I can say view and edit. It brings up the analysis of that part for me, and it shows me all of the cost results in all of the different countries that I looked at for the production of that part. And then like before, I could go through this and I could see which were the low costs. I could look at the graphs and all those sorts of things. Now what I've gone ahead and done here is in each of these cases, I've looked at, I think, 4 different regions of manufacture for this assembly now. So I've got the US, China, Mexico, and India. And what I've done is I've assumed that all of the parts would be made in that region. So for this analysis, we've got that same assembly being done at Chinese labor rates, and I've assumed that all of these parts are going to be made in China. I did the same thing here with Mexico. We've got a Mexican labor rate, and we've got an assumption that all of those parts are being made in Mexico. Now what I've done to this is I've added, I wanted this actually to be 0 profit margin just to keep them consistent and keep that out of the calculation. But I've added tariff and shipping costs to get the products to the US. And so here for China, you can see we've got a 30% tariff. I did some AI research around what typical shipping cost adders would be in percentage terms for products like this one. I gave it a weight and a size, and it gave me here some reasonable number. So I picked a number in the middle. So 5% cost adder for shipping from China, 2% cost adder for shipping from Mexico, and then there's some discussion in here about how shipping routes from India are a little bit more complex. And so we're at about an 8% shipping adder and a 50% tariff for shipping from India. And so what I can do is I can look at a similar cost here now for the cost of production of this product now rather than the individual parts. So if I go to this cost breakdown graph, and again, I'll stack the bars just to make it a little bit easier to look at. But let's look here at the cost of manufacture in China, Mexico, and India. And you can see there we're at $31, $34 in Mexico, and $38 coming out of India. That includes now the cost of the tariffs and the cost of shipping. And I can compare that to my cost of manufacture in the US. So the US is at $37. It's slightly higher to produce that in India, given the tariff coming out of India at the moment. But you can see, as you probably would expect, it's lower to produce a lower cost to produce that part in China and in Mexico. But the thing that we need to consider, and it's a fundamental thing that we try to get people to focus on a lot, is let's look at the underlying design of this product and apply basic design for assembly principles to that and see what kind of falls out of that discussion. And so if I come back to this motor design that's produced in the US, and you can see here I've got 0% tariffs and shipping, so it's being produced here and we don't have to get it here from anywhere else. But at this level here, what you can see is of the 19 parts and 5 operations that it takes to build this product, the software is telling me that in theory only 4 of them are required to meet the theoretical minimum. Now there's obviously some training involved in understanding how this theoretical minimum part criteria works, how you implement it, how you modify the designs, and so on. But by putting the software in this redesign mode, it runs through and highlights to me parts that are potential candidates for elimination, things that I could eliminate through changing the design of the product. And you can see it groups them into categories here. Fasteners, separate operations, handling and insertion difficulties, and then just the sort of heavy hitters, candidates for elimination in my analysis. And so this is fuel for a design team to start to analyze and understand and think critically about the design of their product so that they could come up with potential redesigns that look like this. And so here, this team has gone through a redesign of this product now where they have combined parts with one another, they've changed manufacturing processes, and they have significantly reduced the part count. In fact, it's gone from 24 parts and operations down to 9. Well, what does that do to the bottom line cost of this product? Well, let's add it into our graph. So if I go to that cost breakdown graph again, and again, let's stack the bars. Now let's compare India, China, and Mexico to that. You can see what I've done now is I've come up with a product design that can be produced here in the US for less cost than it can be produced anywhere else in the world, given the costs of shipping and the tariffs that are currently being applied to products manufactured overseas. Now, it's also significantly less, because it's got fewer parts in it, than the thing that I was producing originally in the US. So the DFMA software tools not only give you now the data to explore the costs of manufacture in different regions of the world through our global manufacturing data, but we also give you still the ability to apply these design for assembly principles to your products, simplify the designs of those products, and then understand what the cost implications are of more, let's say, part count intensive designs that are being produced in different regions of the world compared to a more elegant, more simple design that's being produced here in the US. And so if we want to get to a place where domestic manufacture is a thing that makes sense to us from a cost perspective, then simplifying the designs of our products and understanding the cost impact of the design decisions that we're making is really going to be an important step in accomplishing those goals. Thank you for your time, and please don't hesitate to reach out if you have any questions.